Hello all. So in the last session we have discussed about what basically multimodal deep learning is all about and how do we generate image captions, right? So we have studied the basic introduction part to it. So today in this session I would like to talk about image processing with CNN and RestNet, and also we will see how do we extract features with RestNet model. So in the last class we have seen about COCO dataset, right, which we actually use for image captioning. So to that extension I would like to talk about image processing with CNN and RestNet 50 architecture. Okay, so in the world of deep learning, specific architectures have been developed to handle many different applications. So CNNs have been incredibly successful when we talk about image processing, right? So we have particular standard architecture of CNNs for computer vision tasks. Okay, so a good mental model for using a pre-trained model for extracting features from images is that you use pre-trained word embeddings like glove for text. Okay, so in this particular case we can use specific architecture like ResNet 50 or any other architecture of your choice. Okay, so comprehensive treatment of CNN is outside the scope of today's session. I would like to briefly give you a brief overview of CNN and ResNet in this particular session. If you are already comfortable with these topics, you can directly go for image feature extraction with ResNet 50. Okay, but I would like to discuss some basics of CNN, ResNet 50, and then we will see how do we extract features with ResNet 50. Okay, so when I talk about CNN architectures are basically designed to perform three main important features when we talk about image recognition. Okay, so the first one is data locality, the second one is translation invariance, and the third one is scale invariance. When I talk about data locality, the pixels in the image, correlation of the pixels around them. Okay, so what are the pixels in the image and how highly they are correlated to other pixels in the image is all about data locality. When I talk about translation invariance, okay, an object of interest, for example, a bird may appear at different places in the given image. When we see an image, we may observe multiple birds appearing. Okay, so the model should be able to identify the object irrespective of the position of that particular image. So this is called as translation invariance. Okay, an object of interest may have a smaller or larger size depending upon the zooming that we do. Okay, so ideally, when we talk about this, the model should be able to identify objects of interest in an image irrespective of their size. So this is called as scale invariance. Okay, so when we talk about convolutional neural networks, two important concepts that come into our mind are convolutional layers and pooling layers. These are the two important key components that will actually aid CNNs in extracting features from the image. So we'll discuss about these two topics. I'll just give you a brush up of these two topics, in short. So convolutions, as all of us know, are the mathematical operations that are performed on the patches or the areas taken from the image with a filter. Filter is basically a matrix with fixed sizes. We go for 2 by 2, 3 by 3, 5 by 5, 7 by 7 as common dimensions. Okay, as you can see in the following image, it shows an example of 3 by 3 convolution matrix applied on 5 by 5 image. Okay, so the image patches are taken from left to right and top to bottom. The number of pixel this patch shifts by every step, and this is called as strides. Okay, so a stride length of 1 in a horizontal and vertical direction actually reduces the 5 by 5 image to a 3 by 3 image, as you can see here in the figure. Okay, so the specific filter that we have applied here is an edge detection filter. You can use any other filter of your choice. Okay, so prior to CNNs, computer vision relied heavily on handcrafted filters. Okay, so there were filters called Sobel filters, for example. Okay, so you can choose any filter of your choice. And then next, the second important concept that we talk about as one of the important techniques in CNN when we talk about image processing is pooling. Okay, so once the values from the convolution operation have been computed, we go for pooling. Okay, so pooling is basically an operation that can be applied to patches to further concentrate the signal in the image. Okay, so we have average pooling, we have max pooling, of which the most common form of pooling is called max pooling, that you can see here in the following diagram. Okay, so it is as simple as taking the maximum value in the patch. Okay, so as you can see here in the diagram, we have shown max pooling on non-overlapping 2 by 2 patches. Okay, so we have 2 by 2 4 patches. On the non-overlapping we have seen max pooling. So from each thing maximum value. So in the first patch 6 is the maximum, in the second patch 8 is the maximum, in the third patch 3 is maximum, in the fourth patch 2 is 4 is maximum. So we go for this max pooling operation. Okay, so another pooling is the averaging. Okay, so while the pooling reduces the complexity and computational load, it also helps, modestly with scale invariance. Okay, however, there will be a chance that your model overfits and does not generalize well. Okay, so in that case we go for dropout technique that will help with regularization and enable such models to generalize better. Okay, so you can go for combination of these techniques which will help build deeper and deeper networks. Okay, so you can also use residual connections that will actually help us to deal with problems further. Okay, now without wasting much time, I would like to give you a detailed analysis of how image feature extraction is done with ResNet 50. Okay, so ResNet 50 models are basically trained on the ImageNet dataset, as all of us know, because we have been working on ResNet 50 since so long. Okay, so this ImageNet dataset basically contains millions of images in over 20,000 different categories. Okay, so the large scale visualization challenge, ILSVRC, focuses on top of the top 10,000 categories for models to complete recognizing images. Okay, so consequently the top layers of the ResNet 50 that will perform classification will have a dimension of 1,000. Okay, so the basic idea behind this pre-trained model is that it is already able to parse out objects such that you can use easily that for image captioning. Okay, so basically we use tensorflow.keras application package, which will provide all the pre-training model like ResNet 50 and any other model of your choice if you want to go for. Okay, now we'll look into the code in this particular session, where we'll do feature extraction. The main reason for using separate session like this is to give us an ability to run feature extraction as a script when you actually develop your NLP models. Okay, so given that we will be processing over 1 lakh images, this process may take a while. Okay, so CNN benefit greatly from the GPUs in computation, so make sure that you are turning your accelerator to GPU if you are using Google Colab, the cloud environment. Okay, now let's get into the code. Okay, so first we must set up the path for the CSV file we created from the JSON annotations. As I told you, the images are actually available in JSON annotations, so we will set up the path for the CSV file. Okay, now once we are done with setting up the path, we load the pre-processed file with caption and the images which are already being taken under the CSV file. Okay, now the ResNet 50 model will expects each image to be of fixed size. Okay, so here let's say 224 by 224 pixels with 3 different channels. Okay, so the input images from the COCO data set have different sizes. So here in this case, when there are different sizes, we must convert that input file into standard ResNet and then train on that. Okay, so we will use the last residual block of the ResNet 50 architecture with dimension 7 by 7 2048 and store that into the individual file. So I'll take the size 224 by 224. I'll read the file with the image path and try to pre-process that particular image. Okay, so please understand the highlighted code here. That is, the special pre-processing function would be used from the ResNet 50 package, because the pixel in the input here are loaded into an array via the decode_JPEG format. Okay, but each pixel has a value between 0 and 255 for each color channel. So that is the reason we pre-process the input function which normalizes the pixel so that their mean is 0. Okay, since each input image have 5 captions, we should only process the unique images in the given data set. Okay, so for that reason I go for unique images. I'll sort all the images and pick up the unique images. Okay, so once I am done selecting the unique images, we will now convert the data set into tf.dat data set. Okay, so I will this way it will make it easier for us to batch and process the input files using the convenience function which we have defined previously. Okay, now as you can see, I'm taking the image data set. I am going to take all the unique images that I've extracted and I'll map that with the given data set. Okay, so for efficient processing and generating features, we must process 16 image files at a time. Okay, so for that reason, the next step, what I do is I will load a pre-trained ResNet 50 model which is already trained. Okay, now you can see the output of this would be the abbreviated food brevity. The model contains over 23 million trainable parameters. As you can see, 23 million trainable parameters, and we don't need the top classification layer as we are using the model for feature extraction. Okay, so we will just define the model with the input and output layer. Here we have taken the output layer from the last layer. We could take output from different parts of the ResNet 50 architecture where your pre-trained model is being taken from. You can change the definition of the hidden layer variable. Okay, in fact, this variable can be a list of layers, either the top, bottom, or anywhere in between from the pre-trained model that we have chosen, in which the output of the features extract model will be the output from each of the layers. Okay, so once you are done with this, we will create a directory and set up that to store the extracted features. Okay, I'll make directory and save all the prefix, that is already saved features. Okay, now this feature extraction model can work on batches of images and try to predict the output. Okay, so the output is 2048 in this case. Okay, you can run this code and check. The output is 2048 patches of 7 by 7 pixels of each image. As you can see, 7 by 7 pixels of each image. If a batch contains 16 images, okay, so that would be a sensor of dimension 16772048, where we store the features of each image as a separate file while flattening the dimensions. Okay, so each image then can be converted into a sequence of 49 pixel with embedding of 2048, as you can see here in the code, which is specified clearly. Okay, so this could be actually a time consuming operation depending on your computing environment. Okay, so if you work on Ubuntu Linux box with GPU turned on, that will take approximately half an hour time. Okay, so once you're done with the feature extraction model, this last step would be data pre-processing, that you can train and work on the models. Okay, so we can include special tokens to signal the start and end of the sequences. You can use any of the methods that you have learned from text generating with RNNs and GPT-2 transform models, etc. Okay, so here we have used slightly different way of accomplishing the same technique to show how do we accomplish the same objective in different ways. Okay, so you can go for pre-processing and feature extraction and complete the feature extraction by using ResNet 50 pre-trained model. Okay, so once you're ready with this model, the next step would be defining the transformer model, and then you'll be ready to train the model. Okay, so in the next session I would be talking about what transformer model is and how do we train that particular model. So here I end this session by just telling you that you can use CNNs for image processing, and you can also use ResNet 50 model for image feature extraction. Thank you so much.